Okay, so today we're going to be looking at question number 5 in chapter 4 of magnetism, which is where is the force of attraction is the strongest on a magnet. So we look at the options here is A, B, C, D at the poles, above the magnet, in the middle, and below the magnet. So we can start by deducing the wrong answers first, and of course to be doing that we need actual magnets. So since I don't have one, we can just assume that these two are magnets and the tip are the north poles and the end here are the south poles. Now if we say it's in the middle, if we actually have real magnets, if you put them in the center like this, it's very much to say that there are no attraction or repellent that much. So actually in the middle of a magnet is where the force of attraction is the weakest. So therefore we can cross out that answer, cross that one out, right? And let's look at option B and D, below or above the magnet. So if we have circular magnets right here, it doesn't make sense to say which one is above, which one is below. So we need an actual rectangular magnet. So let's assume this is an actual magnet. Then it doesn't really make sense if the force of attraction above or below is stronger than the other. I guess in most cases it really doesn't, so it doesn't make sense. So B and D is also wrong. So the final option is at the poles. Now why is that? So at the very end of the poles is where the attraction of the force is the strongest. So if you put that on the tip to the tip, it will repel of the same poles and it will attract on the opposite poles. So if we look back on option B and D about the magnetic field, it doesn't make sense if a magnetic field above a magnet is stronger than the magnetic field below it. It's always a radial magnetic field which goes in the same direction, the same distance, and it with the same strength. So it doesn't make sense if the strength of above the magnet is stronger than below or vice versa. So that leads to the last option, which is at the poles. Thank you.